today in 5.3, guys, side conversation stop, please. Thank you. In 5.3 last week, we talked about similarity. Similar figures have congruent corresponding angles and proportional corresponding side length. Okay, so now these triangle similarity theorems that we're going to look at, there's 3 here on the front. You can see AA, SAS, and SSS. Okay, these are the 3 triangle similarity theorems that prove, okay, that 2 triangles are similar. So AA stands for angle, angle. So if you know that 2 different sets of corresponding angles are congruent, then you know that the triangles are similar. Okay, so the angle-angle similarity theorem says if 2 pairs of corresponding angles are congruent, then the triangles are similar. So here's a couple, this graphic under where it says AA similarity shows 2 different sets marked congruent, one set with 1 arc and the second set with 2 arcs. Okay, y'all understand that if we know that these 2 sets of angles are congruent, doesn't the third set have to be congruent? Because the triangle sum theorem says that all triangles add to 180. So if we knew these 2 angles and we found the third, and then we did the same thing here, those would also come out congruent. So it's angle, angle, angle. All 3 angles are congruent, okay? But you only have to know 2, because if you know 2, then you would be able to find the third, okay? So it's, you just have to say angle, angle. You don't have to do all 3 angles. I didn't realize this music is still playing. Hang on one sec. Okay. Now, sometimes triangles are drawn side by side in the same orientation, and it's easy to see which angles are supposed to be corresponding. Okay, so for instance, this example on the right side, triangle ABC and DEF. Okay, notice I said ABC in alphabetical order. Okay, and that went from the 1 arc to the 2 arcs to the no arc, right? And then in this triangle, I can see D has 1 arc, E has 2 arcs, and F has no arc. When you name your triangles, when you go to write what's called a similarity statement, okay, you are naming the triangles and writing them in corresponding order. So when you go to name the first one, you get to name it in whatever order you want. I tend to do alphabetical. But so if I name this ABC, and then I use this symbol, remember the tilde is the symbol for similar. So this would read triangle ABC is similar to triangle blank by AA. So by the angle-angle similarity theorem. So we need to name the second triangle. You get to choose the name of the first triangle. You have to do the second triangle in a specific order to correspond. So which angle is congruent to angle A? D. So since this triangle started with A, this triangle has to start with D. Okay, and then it went B. Which angle is congruent to B? E. And then we don't have C and F marked congruent, but we know they would be because the other 2 are. So C corresponds to F. So again, naming of the first triangle is your choice, your decision. Okay, naming the second triangle, the similar triangle, does require you to pay attention to which angles correspond. Okay, now in this second one, this one here in the middle, okay, you've got a set of parallel lines. Nothing is marked congruent here. However, we learned back in Unit 3 about parallel lines and transversals, and we know that if you have 2 parallel lines, which these are, and a transversal, you can look at either one first. I'm going to look at this blue one first. What type of angles are created?
Supplementary.
When you have parallel lines and transversal, you either get congruent angles or supplementary angles. Any 2 angles you pick will be one of those. Now, with angle-angle similarity, we're trying to find corresponding angles congruent, right? So looking in this, when you see this like Z shape, okay, so this zigzag between parallel lines, those angles created, those are alternate interior angles, aren't they? And we know that alternate interior angles are congruent. So I can say that angle R is congruent to angle S. Now I could also look at that zigzag between the red parallel lines, connecting it with this green one. Look at the green as the transversal. So it'd be a backward Z, right? Okay, same thing would happen. Those interior angles, those alternate interior angles would be congruent to each other. So angle T is congruent to angle Q. Okay. Also, what else is happening here in the middle?
Ooh,
Vertical angles. So I know that this angle is congruent to this angle because they're vertical angles. So in this one, you could have picked any two to be your two angles. We actually know all three sets are corresponding, but now I can write my triangle similarity statement and I know which ones correspond. So since the top triangle was named TRP, what order would I have to name this bottom triangle in?
Q.
Good. So I'm going to color code this. So since we started with T, that's the one that I did in green, we have to start with Q, the green one, in the bottom triangle. And then we went R, which was the blue. So we have to go to the blue angle, which is F. And then we went to P, which was that vertical angle in the middle. And so that's also going to be P here. Are we understanding getting the corresponding names correct? Okay. That's the trickiest part. Knowing whether or not they're similar, I don't think is going to be much of a struggle for y'all. Y'all are going to make mistakes in your naming. Okay, so be careful. All right, so angle. So if you know two of the corresponding sets of angles are congruent, you know the triangles are similar. Now the other two theorems that can prove similarity are side angle side. Now notice, it's not just any two sides and an angle. It has to be the angle included between the two known sides. So that we call that the included angle. Okay, so that's pretty important. I'm going to underline that. The included angle means the angle where those two known sides meet. So in this picture, under SAS similarity, they've marked the two sides. They put like a little square on one and a little circle on the other. So this is the included angle. It's where the two known sets of corresponding sides meet. Do y'all understand what I mean when I say included angle?
Yeah. Yes.
Okay, it's where those two known sides meet. Okay. Now this image in the middle, these are drawn in the same orientation. Okay, so it's easy to see what corresponds. Okay, so we can see that angle B is marked congruent to angle N. Okay, and then it's not congruent sides, it's congruent angles. What's the side relationship in similar figures? Proportional. Okay, the sides should be proportional. So when we say side angle side, the angle is congruent, but the two sets of corresponding sides should be proportional. So we would set up the proportion and make sure that it's true. So here it would be FB to LN would need to be equal to BE to NN. Is that the only way I could set up the proportion? No, I did the red to red, green to green. You could have done big red to big green, little red to little green, right? There's different ways you could set up this proportion. You're just confirming that it's true. So you can do 24 divided by 16, that's 1.5, and 39 divided by 26, that's 1.5. They are equal. They reduce to the same ratio. So I'm going to put a check on the equal. They are equal, which means they are proportional. Okay, so those are proportional. So we know that the two sets of sides are proportional and the included angle is congruent. So I can say that these are similar triangles by SAS. So if the first triangle was named FEB, how would I have to name this second triangle? Good. Okay, so they went F to E to B, so we went L to M to N. The order of these letters matters. If you wrote them in a different order, fix them. You cannot just have any random order. The order matters. All right, so similar to the last, when we did angle, when you have these triangles drawn like this, a lot of us want to assume, oh, these opposite angles are going to be congruent, but these aren't marked parallel, are they? No. In this one, we had the markings that these were parallel, so we were able to label the angles as congruent. We can't just come in here and label these as congruent without either the parallel markings on these sides or being told that they're parallel in some sort of statement. We are not given that information. So we can't use angle in this one. We can use the vertical angles are congruent. That's going to be true. Okay. But now we have some side lengths we have to find out if they're proportional. Now, when you have the triangles drawn like this, a lot of people want to put the 26 to the 10 and the 20 to the 13. Okay. But it's like you've got this upper triangle. You started out like with a rectangle and it like twisted. Like you took the top half and twisted it to make this shape. Y'all understand what I'm saying?
Yes.
Okay, so it crossed those, what were the sides of the rectangle. So this RP started out over here and flipped to this side. So the ones that are actually going to correspond to each other are going to be like the 10 and 20 over here. Now, if you can't visualize that, if that's hard for you, another thing to look at is their length. 10 is shorter than 13 in this triangle, isn't it? 10 is less than 13? So wouldn't the shorter side have to correspond to the shorter side of the other triangle? Okay, so think about it logically that way. So the RP, or excuse me, that's an SP. The SP is going to have to correspond to the RP. So you could do 20 over 10 or 10 over 20. You can decide what order you write that in, as long as you're consistent. And then the QP and the PT would have to correspond. Now, I did the 10 on top of the first ratio, so I have to do the 13 on top. Good. So now, are these equal? Are these equivalent?
Yes.
Yeah, 10 over 20 is half. 13 over 26 is half. These are equal ratios, so they are proportional, which means I've got two different sets of corresponding sides proportional, and the included angle is congruent. So by side angle side, I can say that these are similar triangles. The first triangle, the top one, is named TRP. So I go from the uncolored side to the red side. So on the bottom, when I name this, I'm going to have to name it in what order? Q, S, P. Okay, so I went TRP, so I have to go QSP. And again, it was the uncolored side to the red, so I went uncolored side to the red. You feel okay about that?
I feel confident.
Good. All right, the last theorem. There are only 3 theorems proving triangles similar. The last one is side, side, side. Okay, so you don't have to know any of the angles for this, but if all 3 sides are labeled in both your triangles, you can check the ratios, and if all 3 sets of corresponding sides are proportional, then the triangles are similar. So again, we are checking proportionality, okay, of the side length. Now, some of them are drawn in the same orientation, like this example on the right. So we'll start with that one, okay, because they're drawn with the same proportion. Now, we don't assume that because we don't assume things are drawn to scale, right? But use those angle measures, or not angle, excuse me, use those side length measures. Okay, the shortest side of one triangle would have to correspond to the shortest side of another. The longest side would have to correspond to the longest side. So in these triangles, 15 is the shortest. Oh, I want to do a different color. 15 is the shortest of that triangle. What's the shortest of the other triangle? 24. Okay, so those would have to correspond. So I can check 15 to 24, or you could have done 14 to, or excuse me, 24 to 15. Doesn't matter which order. Okay. 20 is the middle length. So it would correspond to 32 because that's the middle length. And again, I did the 15 on top. So I have to do the 20 on top here. Okay. And then last but not least, 25 is the longest. 40 is the longest. So I would have to do 25 over 40. And guys, y'all can use a calculator to divide these and get what the ratio is. You don't have to do all of your reducing of fractions by hand. All of these reduce to the same value. They all have the same ratio, which is 5/8. Okay. So how would I name this I know that these are all proportional. This is equal to this is equal to this. Yes. So they are proportional, but I need to name that triangle in the correct order. So yeah, we went G, H, I. So we went green, blue. So we got to go green, blue. So Q, R, S. So those triangles are similar by side similarity theorem. Okay. Now this one's a little tougher because they're not drawn oriented in the same direction. Okay. This other triangle is like rotated or reflected down. Let's see what it is. It is. Yeah, it's like it's rotated. So we have to look at those measures. So the shortest side would correspond to the shortest side. So I would say 10 to 14, or you could do 14 to 10. Again, it does not matter. Okay, then the middle length is the 21 and the 15. And the longest length is the 28 and the 20. Now, if you reduce all of these, if you do all of this dividing, they all come out the same, okay, which is 5/7. Okay, so this checks out. Yes, they're equal. So yes, I can prove, just like the last one, by side, that these are similar triangles. How would I name that second triangle? I went A, B, C, so I went green to blue. E, F, D. I would have to go the green to blue. Or do we understand similarity theorems? Okay, so there's three options. Angle, side, or side. You had to find proportional sides and say if they were similar, but I don't know that you had to give the reason yet.
I don't know.
Okay, so let's try some on the back. All of these are the same question. I need y'all to stop talking. All of these are asking the same thing. Are the triangles similar? If so, state how and write the similarity statement. So when it says state how, it's asking you to give angle, side, or side. Okay, and then stating the similarity statement, that's what we were filling out, like to name the triangles in corresponding order. Okay, so in these two triangles, I've got a nested triangle. We talked about this in 5.3. Okay, we've got a nested triangle, and these two angles, the bottom left corner of the small one and of the outer one, are marked congruent. Okay, and then this upper angle, X, isn't it a part of the small triangle and the big triangle?
Yes.
So obviously it's going to be congruent to itself, isn't it?
Yes.
Okay, so how many angles, how many corresponding angles do we know are congruent in these two triangles?
2.
So that rule would be what?
Side. SSS. Side.
I don't know any side length here. What do I know?
Angle. Angle.
Angle, angle. I know two sets of angles that are congruent. So yes, they're congruent by angle, angle. Now we have to give the similarity statement. So this is where we name the triangle. And we say triangle blank is similar to triangle blank. Okay, so we have to name them. If it helps you to color code your corresponding sides, you can. In this one, it's the angles that we know. So I think this one's going to be pretty easy. If I start with the small triangle is WXV. So I would have to name the big triangle in that same order. So W is congruent to Z. X is congruent to itself, right? And then so the other one that must be congruent is Y, must be congruent to V. Okay, number 2, we've got the parallel markings on here. So I know alternate interior angles are congruent. I also know vertical angles are congruent, right? So I can say yes without knowing any side length because of angle, angle. Yes, these are similar triangles by the angle, angle similarity theorem. But now I need to give the triangle similarity statement. So I actually have to name these. So what do y'all want to name the one on the left? H to J to K. So H is the red one, so I know I have to start the other one with H as well. And then you said J, that's the green one, so the other side has to go to F. And then K corresponds to G.
Yep.
All right, in number 3, we know one angle is congruent. 120, 120. Okay, and then we know the side, angle, side. Very good. Okay, because it's the included angle between two marked corresponding sides. Now, that's actually, I'm not going to highlight those tick marks. I actually would like you to squiggle out those tick marks. These are not congruent. I don't know why those tick marks are there. They're obviously, they were trying to mark them as corresponding sides, but you should not use tick marks for that. Tick marks mean congruent. Okay? Maybe they were trying to trick you. Very tricky, tricky. I'm going to color code. Color coding is better for marking corresponding. So I'm going to check if those ratios are similar. So 4 would be to 6. As what? 4 would be to 6. As 6 is to 9. Now, are those equivalent? Do they both reduce to the same ratio?
Yes.
2/3. 2/3.
What happens if it's not the same?
Then they are not similar.
Yeah, so you just put no.
So this one is a yes. Yes, they are similar. Yes. And it's by side, angle, side. Now the triangle similarity statement, you get to pick the name of the first one, and then we'll put it in corresponding order for the second one. So how do y'all want to name the small triangle?
LMN.
LMN.
NLP.
Now look at this. Sometimes it's harder to see. N, that was the red angle. So obviously this one has to end with R. Okay, because those are corresponding. Now, LM is the uncolored side, if you will. So QP is the uncolored side. But can I name it PQ or QP? Does it matter? It does matter. Okay, so we have to make sure we're getting it in the right order. Okay, so I want you to see angle L is between the unmarked and the blue. So you could go ahead and add these markings in here. That was supposed to be purple. Unmarked and blue. So Q is going to correspond to L. So that leaves P corresponding to M. Now these were drawn in the same orientation, so that was a bit easier to see. Can the side conversations please stop? Thank you. All right, now a nested triangle. This is another nested triangle. They did not mark these parallel, and they didn't give us these angles as congruent, so we can't assume that they're parallel. So the only angle we know that's going to be the same in the small triangle and the big triangle is the angle that's a part of both. L has to be congruent to itself. Okay, so we have to look at the side length. Now, this 3 is not a side length of a triangle, is it? What is the side length of the big triangle? 9. Okay. What is the right side length of the big triangle? 15. So when I set up my ratios, I'm going to look at the small triangle length to the big. Okay. I'm not looking at that little piece. I'm using it to get the total length, but I'm not using it in the setup of the ratio. So my ratio can be 6 to 9 or 9 to 6. It doesn't matter if you go big to small, as long as you're consistent. So I went big to small, so I need to go 15 to 10. And I'm asking myself, are these equal? 3 halves, right? For both? So those sides are proportional, and we know the included angle is congruent to itself. So this is a yes by what? Side angle side.
Are you supposed to put the largest number on the top? What if
You can do this. You could have flipped as long as you flipped both.
Okay.
They're still equal.
Okay.
Okay, so now we need the statement. What do you want to name the first triangle? Okay, so we're doing the small one first. L, K, M. L to K to M. So then we would have to name the large triangle, also starting with L. And then we'd have to go along the purple side to E. And then across to the blue side, J. Okay, so we did 2 by angle, angle. We did 2 by side angle, side. I bet you can guess what the last ones are going to be. Okay, so I know no angles, no angles. I just have to set up the proportions. So smallest side, what's the smallest side of the other triangle? 21, right? Okay, so 7 is to 21. And again, I don't like that there's tick marks on here. Ignore those tick marks. These are not congruent. Okay, so then the middle side length is 12. The middle side length is 30. And then the longest side is 15. And the longest side is 45. Okay, so if you check all of those, okay, they should all reduce to the same thing if they're proportional. Okay, and when I do that, 12 over 30 does not reduce to the same thing, does it? Okay, so this red one reduces to 1/3. This blue one reduces to 1/3. But the green one reduces to what? 2/5.
Good job, Zach.
So they are not equal. So my answer here,
No.
no.
You have to put an explanation or just keep it. No.
No, you have to be real excited about it. Put that exclamation point. gotta yell it.
Can you put,
No,
do you put FSS too though?
no. Those three statements, SSS, SAS, and AA, prove similarity. So if your answer is no, they're not similar, you don't put any reason. Okay. We good with that one? Okay. So then let's see. Says, are the two triangles similar? Okay, we got to find we have the nested again, so we know angle L is congruent to itself. So we know the total length, and we know these little portions. Okay, so I need to actually get this side length of the small triangle. What would I do to get that? Yeah, if I subtract 88 minus 56 to see what's left, I get 32. Okay, and 32 would correspond to 88 in small to big. Okay, and over here on the right side, how would I get this length from L to M? Which is 52. So 52 would have to correspond to 143. So 52 over 143 and 32 over 88. They do both reduce to the same, which is 4 over 11. So they do come out proportional, and I've got the included angle. So these are congruent, or not, excuse me, these are similar by what? I did side angle side, but also I could have checked this third, since they gave us the measure down here. I could have checked this one. Is 44 to 121 also equivalent? It is. So I could have also proven this by side, side, side. So there was two ways to prove it here. So I could prove it by side, 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 or by side, angle, side. So then when I name my triangles to give my similarity statements, what do you want to name? Let's go small first. What do you want to name the small one? LKM is what I heard first. So I would have to start with L for the large triangle. And then what would correspond to K? D. And what would correspond to M? E. Okay. I feel like most of y'all have got it.
Yeah, I got it.
We're going to practice it. This is also Alex today. Okay, we are also using Alex. Yeah, hang on. I didn't link it here in the calendar yet, but if you go to your module, you should see, yeah, today's assignment is in there already. It has to go, you have to go to Alex. Again, guys, it's, I hope y'all did this with 5.3 already, because it was an Alex. But remember, you're going through McGraw-Hill on your SSO portal to the Honors Geometry Alex, okay? And you should see the assignment there. If you need to finish 5.3, you can. It's late now, but you only get the late points taken off the problems done late. So if you did part of it on time, you'll get full credit for that part, and then late points off of what you're doing late. Okay, so today's is 5.4. It is due. Can y'all please listen so it's clear? This is not going to be due till Wednesday, because tomorrow we have the Veterans Day ceremony, and so it's a slightly altered schedule. And I don't believe it won't affect y'all for my class, but it will affect my fourth period. So since they don't have as long with me tomorrow, I'm not making this assignment due tomorrow. I'm giving y'all through Wednesday. Okay. So y'all have a couple of nights to get this one. Actually, 3 nights, because you have tonight, tomorrow night, and Wednesday night, because it's 11:59 Wednesday is when it's due. Okay. I would get it done before that, because there will be more practice tomorrow. Okay, but you do have some extra time for what you don't finish in class or in cat track.